Hey everybody, Mr. Oglesby here. So today we're going to be covering atomic structure. Now for this, you do need to make sure you've got your notes, you've got something to write with, and then you also do need to make sure you've got a periodic table. You can find one on our Canvas page under course resources, but if you can't find it there, you can always just Google, and there's tons of periodic tables that you can find out there on the internet. So let's actually go ahead and get started. So atomic structure, what is it? Well, atomic structure is how we have found that an atom is currently made up, right? And I say currently because we could learn something new and it could change our thoughts on what an actual atom looks like. But for now, we're going to talk about the three big parts that make up an atom, all right? Those three big parts are a proton, a neutron, and an electron, all right? So what are they? Well, a proton is something that has a mass of 1. Now, sometimes I'm asked, 1 what? Well, 1 is actually a relative number. It's atomic mass unit. Yes, a proton technically does have a mass, and it is a very, very, very small number. But for the purposes of this, we just say it's 1 because it's easier to work with 1 than that really, really tiny number. All right, so protons have a mass of 1. They've also got a positive charge, specifically positive 1 charge. So it's positive. Now, what that means is that when we've got those attractive forces, like with a magnet, you've got one side that's positive and one side that's negative, right? That positive side attracts what? Well, it attracts negative things, right? Opposites attract. So protons are positive. Now, where do we find them? Well, we find them actually inside of the nucleus. Now, the nucleus is that dense core in the center of the atom. All right, so we do find them in the nucleus. And our symbol for a proton is P for proton with a positive charge there to remind us that protons are positive. All right, the next one we have, the next subatomic particle we have is called a neutron. Now, neutrons also have a mass of 1. And technically, it's slightly more than a proton, but again, it's not something that you need to worry about. Neutrons have a mass of 1. All right, what is their charge? Well, neutrons are neutral. All right, so their charge is 0. They do not have a charge. Okay, there's no positive or negative quote unquote attraction there. All right, where do we find them? We find them again inside the nucleus. And their symbol is again N with the charge, which is neutral. Okay. The last one we have is the electron. Now, electrons are very, very, very tiny, much, much tinier than a proton or a neutron. And so their mass is actually relatively 0. Technically, there is some mass there, but for the purposes of, again, this class, you don't need to know that. So their mass is 0. Their charge is a negative 1. All right, so they're going to have that negative attraction, just like a proton has the positive attraction. So if you get a proton and an electron near each other, what are they going to do? They're going to attract. Where do we find them? Well, we find electrons in what's called the electron cloud. All right, so the electron cloud is basically, you've got your nucleus, and the electron cloud is everything outside of the nucleus. All right, and then for our symbol, we've got an E with a negative charge there. Okay, so what holds our atom together? Well, atoms are held together because of that positive and negative attraction that's going on inside of a nucleus. And you're like, well, wait. If I've only got protons and neutrons in the nucleus, then wouldn't they all start to repulse, right? If neutrons are neutral and protons are positive, then you would think, okay, well, we've got a bunch of positives sitting in there with nothing else that's going to repulse them, right? Or attract them. Well, you'd be partially right. Yes, we've got protons in there that are positively charged. And so you would think, okay, well, they're going to push against each other. But again, we've also got neutrons. And neutrons, in a way, kind of act like a glue that holds that nucleus together. So how do they do that? Well, neutrons are neutral, but in a weird way. Neutrons, in a way, you could kind of look at them as we've got one side that's positive and one side that's negative. A neutron is kind of a proton and electron stuck together. All right. And that's why the neutron's mass is slightly higher than a proton. Okay, because it's the proton plus the electron. So what holds them all together? Well, the neutrons hold them together, right? Because those protons are going to be sticking to that negative end of that neutron. It's what's going to be attracting it all together, keeping that dense core all kind of packed in. All right. Now, if I'm talking about an atom, and I want that atom to be neutral, all right, what does neutral mean? Remember, neutral means that it does not have a charge, right? Well, I've got protons and electrons in there, and they've got charges. I've also got neutrons, which are weird because they have a positive / negative, which cancels out. So I've got protons with positive and electrons with negative. So how do I make it neutral? Well, I just have the same amount of protons and electrons, right? When I'm looking at this, when I'm looking at an atom, if I'm talking about one that's on the periodic table, when I talk about an atom is always going to be neutral, okay? And that means it's got an equal amount of protons and electrons. When we get a charge, we call it something else, and we'll talk about that another day. But if we're talking about a neutral atom, that's got equal amounts of protons and electrons, okay? So the number of protons, which is the atomic number, is equal to the number of electrons. Okay, so now you know what makes an atom neutral. You know the building blocks of it. So what happens? What do I do with that? Well, what happens in an atom if I change these different subatomic particles? If I change my number of protons, that changes my atomic number. Okay, so it changes my atomic number. Well, what is atomic number? Well, atomic number tells me the identity of that atom. So if, for instance, I have 3 protons, then I immediately know that that's lithium because lithium's atomic number is 3. If I have 7 protons, I'm talking about nitrogen because nitrogen's atomic number is 7. So if I change my number of protons, I change the identity. Okay, I'm going to change my identity. All right. So now I know what happens if I change my protons. I'm changing what substance I have. So what about neutrons? Well, looking back at our things that we know about a neutron, 1, neutrons have mass. 2, they don't have a charge. And 3, they're in the nucleus. Okay, so those are the 3 things I know about them. So they do have a mass. Well, what else has a mass? A proton has a mass. Well, protons, their job is to determine identity, right? So neutrons' job, their job is to determine mass. Okay, so if I change my number of neutrons, what I'm going to be changing is my mass. All right? And that's it. It's only going to change my mass. Now, what about electrons? Okay, so let's look back at our chart right here, our table. So I've got electrons. Electrons have no mass, so we know that electrons are not going to change mass at all. They have a charge of -1. Okay, that's something we can learn about it. They're located in the electron cloud. Okay, that's just where they're found. So what would happen if I change one of them? Well, protons have a mass. Okay, well, we know neutrons are what are going to determine mass. Protons determine identity. Okay, so that's nothing. None of the other things are going to determine identity. Protons also have a charge, right? But protons, again, already have a job. So the only job left for electrons is charge. If I change my number of electrons, I'm going to change my charge, okay? Because we never want to change our number of protons. We will never change our number of protons in terms of chemical reactions. If we change our number of protons, we're changing the identity of that substance, which means we change everything else about it. If we change our electrons, what we're going to do is we're going to change our charge, which is how those chemical reactions occur. Okay, so electrons are all about changing charge. Okay, So now we kind of know the general jobs of the things that make up the atom. So let's look at a drawing, a basic drawing of what an atom looks like. So this says draw an atom of carbon that has 6 electrons and 6 neutrons. Okay, so I know I've got 6 electrons and 6 neutrons. But I need to draw an atom. And so for an atom, I know I need to have protons, neutrons, and electrons. I need to have all 3. Well, this doesn't talk at all about protons. So I'm going to have to think about that a little bit. Okay. So first off, let's give these a symbol. So I'm going to say proton will be a circle. Neutrons will be a triangle. And electrons, let's just kind of make a filled-in circle. I think that's the easiest. So draw an atom of carbon that has 6 electrons and 6 neutrons. So you're thinking, okay, first off, I need to draw my nucleus, right? Because that's where the center is. So I need to draw my nucleus. Well, I know my neutrons are in the nucleus. So let's go ahead and draw those. 1, 2, 3, 4, 5, and 6. Okay, but that's not all that's in the nucleus, right? We also need to have our protons. So how do I know how many protons I have? Well, I look on my periodic table. So this is where that periodic table does come into play. So we find carbon on the periodic table, and what we'll find is that carbon has an atomic number of 6. Well, the atomic number is the same as your number of protons, which determines your identity. So I have 6 protons. So 1, 2, 3, 4, 5, and 6. All right, so there's my nucleus. Now I need to draw my electrons. Well, electrons we know are not found in the nucleus. Instead, they're found in the electron cloud. And that electron cloud kind of orbits around our nucleus. Okay, now some things to know. For your energy levels, the first energy level can only hold 2 electrons. Well, I need to draw 6, right? So the first energy level, I'm only going to draw 2 on it. 1, 2, done. All right, but I still need to draw 4 more. So what do I need to do? Well, I need to add another energy level. How many do I draw? Well, I've already added 2. I need to add 6, so I need to add 4 more. 1, 2, 3, and 4. And where you put them doesn't really matter. So now I've got all my electrons, I've got all my neutrons, and I've got all my protons. So this would be our atomic drawing of carbon. Okay, so what I want y'all to do is I want y'all to actually pause your video and actually try this before I go over it. Okay, so pause your video and draw the atom of phosphorus that has 16 neutrons and 15 electrons. Okay, so I'm going to assume that y'all have paused the video, so let's actually go ahead and draw this. We're going to use the same symbols for protons, neutrons, and electrons for this one. So phosphorus, again, I need to think about what all we have. So I know I've got 16 neutrons. Well, I know those are in the nucleus, so I'm going to go ahead and draw those. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Now, what else is in the nucleus? Again, there's protons in the nucleus, right? So I find my phosphorus on the periodic table, which is P. It's number 15 on the periodic table. So that tells me I've got 15 protons. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. All right, so there's my nucleus. Nucleus is all there. Now I need to start adding electrons. So first energy level, how many can it hold? It can hold 2. 1, 2. Second energy level. Now, we didn't actually go over this a second ago, but maybe some of y'all remember this. Energy levels after that first energy level can hold up to 8. All right, so up to 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Well, how many electrons do I have now? Well, I've got 10, right? I need to have 15. So I need to add 5 more electrons to this drawing, which means I need another energy level. I could not add it onto that same one. So 1, 2, 3, 4, and 5. So that would be my drawing of phosphorus. All right, y'all. So that is all your notes over atomic structure. Please let us know if you've got any questions, and hopefully y'all have a great rest of the day. Bye, y'all.